A friend of me that shares with me that strange love for reel-to-reels gave me this machine and asked me if I could take a look at it and do whatever is possible, whatever is in my abilities to make it fair usable. He did this because he knows I have a fair amateur expertise in those machines. As I mentioned, it's an amateur, not an expertise. I would call it an experience, okay? Just a fair amateur experience. And I will try to do my best to make that thing work. Some problems of this machine, we can see that a cap here is missing, that trim here is missing. If we taking a look at this race head, we can immediately see that this is a 4-track machine, okay, and cosmetically is not perfect, but is not bad. As he told me, this is where the power cable goes. This is the original plug for the power cable for a Revox, and the cable is missing. He doesn't have it, so I will. I can either try and find this plug. This plug is not common nowadays, but the common plug is the plug for computers. So I'm back now. This is the original plug that fits in there, and this is the common computer plug that somebody can find nowadays. So I will ask my friend if he wants me to replace this port with this here, which fits very easily here, so that he can use the common plug that exists today, that one here. Okay, he will lose some originality doing that, but it will be much more convenient, and I will get rid of the safety that is in here when you take this part away. So there is a safety in here. I will get rid of it, and I will take the cable to go directly down. I will ask him, maybe he wants to buy a new power cable, not a new, but okay, a power cable like that to keep the originality of this. I will ask him. Now, I did make some tests to see if it's working. This machine is working, but the capstan motor, which is that's the capstan motor, is very stiff, so it needs to be lubricated, and I will turn the machine all after I lubricate this, so that I avoid damaging it. For this trim here that is missing, my friend thinks of buying this whole plate again and replace it, because this trim, I don't think we are able to find it as a unique part. And he says that he likes the looks of mk3 and mk4 machines. This is an mk2 machine, where this part was grey. Luckily, I have here an mk3 machine, and I have here an mk4 machine. So I can take these parts and put them here to see if they are interchangeable. And if they are, he will purchase maybe whatever front face he wants to put here. But if not, we will have to search. I think that trim here is the same as that trim here. So in any case, he will buy whatever front face he wants, and he can take either only the trim or put the whole face in there. So first, now I will open it and see what's in and show what's inside it. I have shown many times how to open these things. I will not do it again. You take out this plug, and then there are 4 screws. 1, 2, 3, 4. You take them out. You pull all this out, and it comes out. Okay, now that we have this machine lying on pillows here, let's see what we have inside. The motor is very stiff, it stops immediately. It should turn much more, that's why I didn't fire up the machine before. We have all cards here. We can see in all cards we have all the old potentiometers, the old trimmers that are in there. All these need to be replaced because the moment you try to calibrate the machine using these potentiometers, they just collapse in pieces, so they have to be replaced. Rifa capacitors are replaced. Let's see the specs. Yes, by 2, yes, okay, these are the correct spec capacitors that we have here. Anyway, but this rifa there on the capstan control motor speed control board, this rifa is not replaced, we have to replace it. There is a strange thing going on here with these resistors in there. There seems to be 2 resistors in series. This resistor looks okay, and I don't know about this. This is okay, but this. So, from what I know, correct me if I'm wrong, these resistors are acting like fuses. They're very low resistance. I don't remember, 0.5 ohms, I think. I don't remember. And they act like fuses in case one of these capacitors becomes short circuit. So when they are replaced, these resistors, they should not be replaced with higher wattage ones, because that way they don't act as fuses anymore. So I will check later the value of that resistor here and see if what somebody has done here. That thing here indicates that once this capacitor became short circuit and this resistor was burned, so somebody replaced this resistor with 2 resistors. I don't know why, I will see. I don't know what else we have. As I said, I will get rid of this mechanism here, and I will just put a plug here, and I will take the cables downstairs directly. The motor capacitors are the original ones. Okay, let's see. That capacitor. As I see, all capacitors are the original ones. That one, that one. This is the original bridge rectifier. And all the other capacitors, even on the cards, as we have here, all the other capacitors are the original ones. I will first be sure that everything is working correctly, and then maybe I will start replacing capacitors if something looks bad. Or I might not, I don't know, I will see. The speed control board with the original capacitor. If the capstan speed is not correctly, I will have to try and see all these capacitors, but I will definitely change this one first and see what happens after that. It's working, but this should be replaced as a precaution only, even if they look okay. This one looks to be cracked. Can you see the crack here? there is a crack here. So this one is cracked already, so it should be replaced anyway. So that's it for now. My first job is to take out this capstan motor and try to and take out this thing here and lubricate it. This thing is a little bit rusty, which indicates that the machine has remained non-working and in a storage area for long. That's why it is a little bit rusty here. But if it will work, everything will be fine. Okay, first job, capstan motor lubrication. I've done other videos on how to do this, so I will not show it now in detail. I will go through it very quickly. So this is how the motor works now. As you can see, it moves freely. Actually, when I put it all back and I turned it on, it was making a lot of noise, but luckily I had a spare. Doesn't focus. Here I had a spare bearing with me that I bought some time ago when I did the same service, and I used it. This is the old one. Although I put grease, whatever, it was noisy. I could hear it from the beginning as I was touching it, turning it, that I could feel some crick, 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 crick. But I thought that I had to see first. Now that the motor is in place, it works nice. It makes a tiny amount of noise, but this happens to my machines too. It's not a big deal, that tiny noise. But it was much worse with the old bearing. And let's see, small speed. It works perfectly. So, that's it. Motor is working. Let's proceed with the tests. So after taking care of the motor, look how smooth it is now. You see? So after taking care of the motor, I tested the machine, and the playback is perfect. That machine is working correctly for the playback. Only minor problem, I don't know exactly, is that from this side, from this motor and this motor, there is a lot of noise heard. So I'm not sure if it is the motor or the brakes, but I suspect that the brakes are a little bit rusty or dirty, and that's why I hear this noise. It makes a lot of noise also when you fast forward or fast rewind. I tried to record and I realized that one channel was way off, and finally the problem was one potentiometer, this one. I didn't have the exact value, I think this is 20K, and I had a value ready which is 47K, and I put it just to test if it works, and it really works. First I had my other machines like this one here, and I put the record amplifier and it worked. That's why I knew the problem was on the board, and the problem finally was this potentiometer. Actually, I did buy a full set of potentiometers, and I will replace all this because it is suggested to do so. These fall apart when you try to calibrate the machine, but actually these ones and all the others except the one that was bad did not fall apart. They worked correctly. But anyway, I won't leave them on the machine. I will keep them maybe as spare for testing purposes, but I will replace them all with these ones that I found locally, and I was really lucky to find them locally. That's it. I'm replacing all this and I'm testing the machine again. When replacing this, you see that leg here, the top leg must be bent a little bit to be like that, so that it fits on the holes of the board. And also, do you see that plastic thing here? On the other side, I had to break it so that this potentiometer could fit in. So we have to break it there and make it a little bit shorter. Be careful, because the lines here, the conductive lines on these boards are very fragile. You have to do everything very carefully. This is so that you know what will happen if you are not really careful. And finally, after some time and some soldering iron usage, we have all trimmers, all calibration trimmers replaced with proper new ones. So now it's time to test the machine and see if everything can be calibrated properly. Be careful to align the boards with the notches that are back here, and make sure after you put the screws here and here, make sure that they can be moved freely in the knots, so that you know they are not pushed and stressed back. So I took care of the motor, and now the motor is not noisy. Okay, and I had to take care of this spindle here, because it was a little bit bent, more than acceptable level, as you can see now. And I had to use some brute force to put it back in position, as I put this here just to know where to push it to. And the next problem is that there is a lot of noise that can be heard from in here. In here also, but mostly in here. Just listen. here there is also some noise, but not that much. So I think it has something to do with the brakes that are here. It could be the motor, but that doesn't look like a motor noise. I think it's the brakes. So I will take this cover out and see what's going on inside. So I did take out this brake metal tape, and as you can see here, it is very, very dirty. Furthermore, that part here looks a little bit shiny, but I don't know if I need to do something here. But taking out the counter belt and having this rotate freely, it is making some noise, but I think that's not of a problem now. So I will first clean this with either isopropyl or acetone and see if that solves any problem. So using acetone, that thing you can see it's like a mirror now. It's totally clean. Okay, be careful not to bend this while cleaning it. I had to hold it like that and clean it while doing it, because otherwise it will bend and it will be damaged. And now I will try and clean with isopropyl alcohol this time, that thing here a little bit, and then I will see. I did put some grease on this and this where that thing is locked in place so that it can rotate like that freely, and I will see if that solves the problem. So the noise is still here, but I noticed that if I pull this a little bit there, just like that, then the noise is much less, but the brake is okay. So I think I will bend this a little bit so that it stays a little bit more like that. Just listen. And if I have it here, I cannot push the brake and hold it at the same time, but I will show you later that the brake works okay. So I did bend that a little bit, not making too much noise, and the brake works. I have to put a reel on and see if the brake works also with the weight of a metal reel, and if it works, it looks like it's okay. So let's see what we did. That brake works okay. Let's see the other side. The tape is here. And it looks like it brakes fine. So I will leave this brake as it is. Now let's go and see what's going on with this brake. Took out the other side brake metal strip here, which also is dirty on some places. I will try and clean it. The other side is very dirty. I will clean it now and put it back and see if I can fix this. So I put two big end metal reels because this is the worst case scenario about the brakes. and now I wanted to check how they work. Okay, I will leave it go further. Okay, looks like it works normally now. There is no much noise. So I think the brakes are okay. So messing with the brakes of this machine is taking out these three screws and all this out, these three screws also out, cleaning that metal stripe here, messing with these here and bending them accordingly, and putting this spring on other holes, and like that making some trials and see when this will work okay. And I think the best solution I found is as I found it now. So you just have to do this, see if both tables turn freely, and when you leave it, they must stop like that. And now we are on our next problem. And the next problem is that the auto stop sensor is not working. As we can see, it doesn't work, it doesn't stop. We have to stop it manually. The first thing to do is take out this dummy plug and see if the auto stop mechanism works. And it works. So the auto stop mechanism works. I have to see if the problem is the sensor here. The next thing to do is take here my flashlight and apply light here and see if it works. And as you can see, it still doesn't work. So I'm gonna have to measure the resistance. You can see, as you can see here, there are two cables that go to the light sensor, which is in here, and we can measure the resistance between these two and see if it changes in relation to how much light gets on here. So measuring the resistance of this light dependent resistor, we just have to take out two green wires that are somewhere in there. Let me take my flashlight and show you. I don't know if you can see them. Anyway, it's not a big deal, you will find them. There are two plugs there. You take them out and they are here, two green wires. And then you put your multimeter here and you measure the resistance. Now that there is no light going to the diode, to the resistor, we can see that the resistance is about more than 20 megohms. I think this is 80 megohms something. Okay, but when I open the machine, you can see the resistance goes about 25K. Stop the machine, start the machine. So that goes about 25K. That should go to about 2-3K according to the service manual. So 25 is too much, and that means that this light dependent diode is not light dependent resistor, oh god, sorry, is not working correctly. You see? It should have less resistance. If I apply direct light with my flashlight on it, it goes down to 16. Even that, it's too much, it should be lower. Let's go and see the service manual. So that fantastic service manual for this Revox describes here exactly how this auto-stop system works. Actually, when this resistor goes down, the base of this transistor gets higher voltage, so that that goes to on, and as this goes to on, it triggers the auto-stop mechanism. That's how it works. It's not a big deal, but actually this resistor with the light-dependent resistor should go to lower resistance than it goes. Have a look here what I achieved. Pressing play and everything else stops. But if I put my finger here, it doesn't stop. Take out my finger, it stops. If I put my here, so it seems to be fixed. I don't know if it will be fixed temporarily or permanently, but what I did is I replaced a resistor of 500 ohms with 1.6K. I will now show you which one I replaced. So, this is the resistor that I replaced from 500 ohms to 1.6K, because this resistor goes to ground, and like that, if you increase the resistance of this, it makes the base of this transistor higher, so even if the LDR doesn't go too low, the base has enough voltage from the 25 here for this transistor to be saturated and give and make current go like that anyway. Now that we adjusted the brakes, it's a good opportunity to see what the amazing service manual of the Revox says about the brakes. And so these are the forces we have to measure here. And putting a reel on the machine, we have to measure 140 to 175 grams inwards and 60 to 90 outwards. It's the same on both reels, so I have a way that I will show you now that you can measure this. The setup to measure it is a normal reel like that. This is the diameter that is shown on the service manual, and here I have a scale that I used I had this because I used to travel a lot with an airplane, and I used this to measure the weight of my luggage. And as you can see, okay, this is now in grams, and if I pull it down, you see the grams, just pull it like that, the grams increase. And so what I have here some that small thing, and I wrap it around here, and I wrap it also around that thing here. I will show you, and I pull it, and I have this on the machine, and here I measure the force that comes out of this, and this has to be within limits in the service manual. Let me show you how it works. So you see, I hold it here and I pull it like that. You see how I did it there? And this is the way that I measure the strength. Let's see, it's not very easy to do it while holding the phone. For example, this should be between 140 and 175, okay? With this button, it changes to other units of measurements. So this is grams, and I do this. It's 175, which is within the limits because it's the upper limit, but it's okay. Let me show you, let me do it the other way. Okay, this way it should be 60 to 90. So let's see. You see, this is 70, so it's okay. Let's go to the other side. Okay, it's 0. To 80, it's 85. It's a little 60 to 90 it was, so 85 it's normal. Let's do it the inwards. So let's see how much now it is. Wait, I have first to make it 0. It's 155, which is also correct. So, according to the service manual, the brakes of this machine are calibrated correctly. Let me show you what I did here. I had to put a little bit more here, the spring, because so that it pulls it pulls inwards like that, so that the measurements are within limits, and I did the same thing here also. But when the solenoid engages, these are both very free. So I think the problem why this happens, it's because the material that it's in there, this white material that is behind this metal strip here, it has got old, and it needs more force to apply the same brake. But I checked everything and the brakes work correctly. So the brakes are aligned. I'm finished with this. So my friend that gave me this took care a little bit of it, requested that I make the VU meters. Okay, first, this is an mk2 machine, and on the mk2 machines the VU meters do not light up permanently. They only light up during record mode. But my friend that gave me this to take care of it requested that if it's possible that I make the VU meters light up all the time. So in order to achieve this, you have to do this. First, this is a cable that goes on the back side, somewhere in there. Let me see if I can find it. Yeah, there it is. Can you see that leg here? This is where that cable goes, which feeds ground to the two bulbs, that cable here, so they light up when you put record mode. I didn't want this to interfere with what I will do, so I took it out, I secured it, and I will put it back in there, but secured and not plugged in. Then I just put a little cable here, from here to here. You can see it. This is ground for this board. This is ground, and this also is ground, but the ground is fed from elsewhere. And this is live. here. This is 24 volts. So I put this wire here so that both lights, which are one is here and one is here, so they are both lit permanently, and this is how it is. Look, you see? Now they are lit permanently. This is interesting. So you just have to press. I didn't know that. Okay, so you can have it out so that it's not lit, but you can press it in and then it is lit. So my friend will be more happy because he will be able to choose if he wants the VU meters lit or not. That's fine. So I will leave it like that. That's all. I will put this back where it was, but secured with tape. It will just lie there in case someone wants to reverse this. But having this video, my friend will know what I did, so he will be able to reverse it whenever he wants. Well, unluckily I had to get rid of all the cables that I put there, because as I showed earlier, with this bridge wire that I put, the moment you press these two buttons like that, it would trigger the recording mechanism, even if you were only on play and not pressing this also. It started erasing my tapes, and it took some seconds until I realized that it was erasing my tapes, because I couldn't hear any sound from the playback, and I thought, what's going on? And it was erasing because these were pressed. Okay, too bad. I think this will remain with the VU meters not light it up while playback. I'm sorry, my friend. Now that the front cover is, the bottom cover is out, it's a good chance to make a good head cleaning and put transparent tape, as you can see here. This is transparent tape, okay, and I'm using this to align the heads. Well, not really. I'm not gonna align the heads if they are already aligned properly, and I think these heads are indeed aligned properly. I mean height, okay, I'm talking about height and zenith. They seem to be okay. Let's see. Okay, so I will adjust the azimuth with my test tape. Let's see, and also the erase head looks to be aligned properly. So I will mess only with the azimuth. I put everything back together, but leaving the back side open here, because the next job to do on this machine is the calibration. Okay, the first thing to do is the calibration of the azimuth of the playback head. That's what we have to do first. But this will be done by using test tape that I have. But before doing this, the first job is a proper demagnetization of the heads. Otherwise, you risk damaging a little bit, maybe, the test tape. So, demagnetization, test tape, azimuth of the playback head, and I will show you how. So, to calibrate a machine, you need the following. What I have Listen, since I'm an amateur and I do all this for fun, really don't take my advice for granted. Okay? This is what I do. If you want, follow it. If you don't want, don't follow it. What I have here the machine. I have my oscillator, which is hooked to the line output. To the line output here. It's down there. Of the machine. I have a signal generator which is hooked here to the line in of the machine, and as you can see I bridged the input here so that I'm sure that definitely the signal that goes inside is of the same level. And here I also have my custom VU meter here. And I just use this as an additional measurement thing. It's not very important. I have this calibrated to 1 volt max or 0.7 RMS, about 0.7. The other thing I have is ceramic screwdrivers, and I use this to align the heads with the screws here and to use them in all these potentiometers here, trimmers that are in there, which I replaced from the original as I showed you before. And this is generally the setup we need to calibrate a machine properly. So let's make sure our setup is working properly. I put the line in of the signal generator here, and I put the line output to the oscillator. So volume is working, balance is working, recording level one channel is working, recording level the other channel is working, and let's see, our oscillator works okay because frequency changes are shown. Here I have some measurements. This is one channel, this is the other channel, minimum, maximum, RMS and frequency. That's what I want to be able to see when I make measurements here. So our setup is working. Let's proceed by calibrating the azimuth of the playback head. So the azimuth is managed by this screw here. Okay, so you turn it both directions like that and like that, and you check the screen and see. So here my test tone is playing a 700 Hertz, and as I you see that as the phasing changes, so what we only have to do is to make the two phases being exactly above each other. Just like that. First we do this on the 700 Hertz to be sure that we don't jump a whole phase, and then we do it on higher frequencies that are on my test tape later, so I will show it again with the higher frequencies. So now my test tape plays a 16 kilohertz tone, and I aligned the azimuth. It's not very stable, and here very slight changes will make it move, even touching the head with the hand, you can see. Even touching with the hand, so I just put it as good as I could, and now the azimuth of this head is calibrated. I use some nail polisher to secure the head, just like that. Okay, it's not a professional solution, but that's the only thing I have. Next thing to do is that we make sure that the balance is okay. So we put this to maximum, this to maximum, this to maximum, and we feed a tiny signal, otherwise the output will be very high. We feed a very tiny signal, and we put the balance, so that we make sure that both outputs are of the same level. For example, now it's 3 volts on one. No, that's getting lower. So here both signals are on the same level, and this is set to the middle, and now this here we don't touch it again. Okay, let's see, it's still the same level. Yeah, okay, generally the same, and we don't touch that here with the balance. We don't touch it again. Next thing is the playback level. Next thing to do is I put that to about 7, and I feed a 0 dB signal from my test tape, and I calibrate these two trimmers here so that the output is about 800 millivolts both channel. It's more important for the two channels to be equal, and the actual level is not that important, so let's see. So both channels are on 800 millivolts, and that's where I'm gonna leave it. Well, after doing all this, we are sure that we calibrated the playback side of our machine, and now it's time to calibrate the recording side of our machine. For the calibration of the recording, I should use new tape, which I don't have, so I will use used tape, and I'm sorry to my friend that this is not gonna be perfect, that's the only thing I can do. This part is finished, we're not gonna mess with this part anymore, and we will mess with this part, which is the recording side. Okay, all the indications here are self-explanatory, so I don't have to explain anything here. The first thing to calibrate is the bias. Actually, no, the first thing to calibrate is the azimuth of the recording head. To do this, we feed a signal. Now I'm choosing 4 kilohertz, so 4000 hertz, and I'm touching the record level so that both channels have equal level, just like that. About, it's not very important exactly. And then I start recording, and I monitor the output from the tape, and I check that both channels are in phase. So this is input, this is output. Now I will play record, and I see the output, and I see that it's too bad, so I'm gonna have to feed a lower frequency signal so that I am sure I don't lose one phase. So now I'm feeding a 1.5 kilohertz signal, and now I can see which phases are close to each other, and I can adjust the azimuth of the recording head so that both signals are in phase, just like that. Just like that, and then continue with the higher frequency signal. So now I'm feeding a 7 kilohertz signal, and I'm monitoring the output. This is the input, this is the output, and as you can see, both channels are nearly in phase. Let me increase let me put it to about 10,000, let's see. And as I can see, still both channels are in phase. So I think azimuth of the recording head is adjusted. recording head secure with nail polish, and let's go to bias. For the bias, we put all trimmers to minimum, and we just put the recording level, this and this, to about the middle. Now we will not calibrate the recording level, just the bias first. Okay, so everything is to minimum. What we do is we feed a 1000 Hz signal, and we try to, by calibrating the oscillator, we try to find the maximum output. And then, after we find it, we lower it to about, we keep on like that until the output is lowered to about 4 dB, they say. I don't know exactly what's this 4 dB. I will just lower it like from 1.3 volts maximum to 0 volts maximum or something like that. I will see on the way. So now I'm recording a signal of 1000 Hz, and I will start increasing the bias level until I find the maximum. Let's see, maximum is about there, and then I will do it clockwise until I go a little bit lower, let's say there. That's what I'm gonna do. So that I will have to do for both channels and both speeds. So 4 times I will do that thing. I just have to make sure that I do it equally on all channels. For example, after I find the maximum spot, I increase the volume from here until I reach, for example, 1.3 volts, and then I turn it clockwise until the 1.3 maximum goes to 1 maximum. Okay, that's how I'm gonna do it. So after adjusting the bias for both channels and both speeds, we feed an about 10 kHz signal, as you can see here, and we mesh with these two trim pods and these two, and we do the same for both channels and both speeds, so that we have equal signal on input and output, equal strength signal. Okay, that's what I'm gonna do now, and come back later. So I did calibrate the equalizer. I couldn't do it very accurately. I don't know. I could not see a very clear signal. But anyway, the last check will be by ear. That's the amateur way. But before I calibrate the VU indicators that I'm gonna do now, I have to say that because I'm not really familiar with all these dB and volts and comparing the two stuff. So before I made any changes to the cards, I came here and I took some notes where the VU meters were. So the output level to 8, the recording level to 8.2, the output maximum was 1 volt, and the VUs would show -3, and this was on 1000 Hz. I did this with some other cases here, and I will calculate the VU meters so that I now get the same results like these, and then I will make sure that they are both equally calibrated. Let me say something. The VU levels is not very important to be calibrated on the correct level. There is no really very strict correct level. They just have to be very well balanced to show the same level, both of them. That's very important. and not the actual level. The actual level can be roughly calibrated. It will just make your recording a little bit lower or a little bit higher. As long as there is no distortion, this is not very bad. So I'm using my phone to do this, and these are the results. 1000 Hertz. Maximum output about 1 volt. This to 8. This to 8.2, a little bit above 8. According to my measurements before, both VU meters should show -3, and that's what I'm gonna do now. And now it's time to calibrate the recording level. So, output to maximum 1 volts, this to 7, recording levels set so that the VU meters show 0 on both channels, and I will use these two trimmers here so that input and output are exactly the same level. So let me show you. This is output from tape, this is input. This is output from tape, this is input. So they are exactly equal, both levels. Exactly, okay, nearly equal. And that's how recording level is calibrated. Actually, there were some more things that had to be done, and I'm making a video of it so that the user knows what has been done on his machine. This is the original bearing that goes here, and it was very stiff, and I happened to have one which is not of a good quality, but now it works much better than this one, okay? And second, the original washer here, there should be 2 washers, and I found only one, so maybe one washer is missing, but I have a bunch of such washers, so I will measure the thickness of them, and I will put equal thickness on the other side. So the thickness of the original washer is 0.2 millimeters. The thickness of my washers is 0.1 millimeters, so I will put on one side 2 of my washers. I decided that it's better to use a bearing for this side also instead of the fixed guide. Although the specifications have the original machine has a fixed guide, many do this modification. I think this would help a little bit with the old motors here, because I think they are a little bit weaker than normal, than original. But this is easily reversible anyway if the user requests. You can just take out this and put the new ones. So I think now it will be okay. So now the machine turns freely and very quickly. Before it would make strange noises here, and not here, but here it will do a lot of stuff like that would move frequently, but now it looks very smooth. Brakes are okay, and the fast rewind that had some problems now works very easily, very quickly, and I like it just like that. Forgot that I had also to replace this capacitor. The others here are already replaced, so to do this I insert a screwdriver like that so that it holds the cables back there, and by doing that I have free space here to take out this capacitor without having to take out that board. New capacitor in, old capacitor out, and we are ready to go. So now everything is calibrated, but there is always a last check to do, and this is the human check. So feed in a song you like, put on your earphones. Where do I have them? There they are. Feed in a song you like. Better to have good highs, good treble and all this stuff from the phone, from whatever. Put on your earphones here and check input and output and see if they are exactly the same. And if they are, you have successfully calibrated a deck. Okay, now some loyalty-free music. Recording level adjusted, and this is the input. I'm gonna start recording. That's channel 2, channel 1, stereo, as we can see, nearly no difference. Let's switch to low speed. Input, output, okay. That's it. I can hear it pretty fine. Low speed loses some treble, which is normal. Okay, if anyone wants more treble, you can increase it from your amplifier, but that's how it is. I mentioned that if I put this to IEC instead of this, then we gain some treble there. So listen to that now. It's nearly the same. I don't see any difference. So I consider this finished. I will ask my friend to come and get it.